Wow. Wow. Oh, wow. I don't need this from you. I don't.
Two. Yeah.
There are four forces acting on an airplane that cause it to fly: the lift, the push, the drag, and the weight.
The flight of a paper airplane is a good example of conservation of mechanical energy. In this scenario, we have a good paper airplane. A good paper airplane will have a slow loss of gravitational potential energy and a slow gain of kinetic energy. Why is it conservation of mechanical energy? Because during the flight of the paper airplane, the energies are transferred from gravitational potential energy to kinetic energy, therefore keeping the total energy in the system a constant at the beginning and at the end. Before the airplane is thrown, the only energy that the paper airplane has is gravitational potential energy, since it's off the ground, and it also has zero kinetic energy since it's not moving. During the flight, the paper airplane gains kinetic energy as it flies through the air, but at the same time, the paper airplane loses gravitational potential energy as it gets closer to the ground.
Contrastingly to a good paper airplane, a bad paper airplane will lose its gravitational potential energy rather quickly, while having a fast gain of kinetic energy. These differences will cause the bad paper airplane to fly for a much shorter distance. The principles of conservation mechanical energy will still apply in this situation.
So what happens when we change the angle of the launch of the paper airplane from 0 to 45 degrees? Will the distance traveled by the paper airplane change? If we keep the initial velocity the same for both flights, then the work equations will come to this. For the non-angled one, distance equals work divided by F times cosine. When work is 100 joules, the force is 10 newtons, and the angle is at 0 degrees, this equals to 10 meters in distance. For the angled one, the only variable changing is the angle, which is 45 degrees, which then equates to 19.01 meters. This shows that the changing of the angle to 45 degrees results in greater distance.
That's